Hello, my wonderful and beautiful students. You're welcome to once again another presentation from Ministry of Education, Kaduna State Radio TV e-learning platform. My name is Mr. Philip Mamman. I'll be taking you the subject chemistry, and the topic of discussion today is periodic table and periodicity of elements. I'm sure in your SS1 you must have come across the first 20 elements, their atomic masses, as well as their atomic number. That will be the basis of our discussion today. Follow me as we get tips on how to pass your examination in the forthcoming exams. This topic has the following content: introduction, brief history of the periodic table, definition of terms, periodic table, periodicity of elements, periodic laws, and of course, relationship on the periodic table, classification of the periodic table, and periodic properties of elements and their variation. I will start with a little introduction. So many scientists have tried to classify the elements, but prominent among them is in 1863, English chemist John Newland divided the then discovered 56 elements into 11 groups based on their character. But the most pronounced scientist that did very well in the periodic table is the Russian scientist Dmitry Mendeleev. In 1869, the Russian chemist was the first to observe that if elements were listed in order of their atomic masses, they show regular or periodical or repeating properties. He formulated his discovery in the periodic table of elements and now is regarded as the backbone of chemistry. Of course, chemistry is standing on the basis of this discovery of Dmitry Mendeleev. But crowning his achievement is the fact that he was able to prophesy or predict 7 elements that were not in existence. And he was able to place them on their groups as well as give their properties. He published his periodic classification. Crowning the achievement of Mendeleev's periodic table lies on his prophecy of then undiscovered element. He published his periodic classification. The elements gallium, germanium, and scandium were unknown. Mendeleev left space for them in the periodic table and even predicted their atomic masses and other chemical properties. 6 years later, gallium was discovered, and his predictions were found to be accurate. Other discoveries followed, and their chemical behavior matched the prediction of Mendeleev. The definition of terms. The periodic table, as you all know, is an arrangement of chemical elements which are organized on the basis of their atomic number, electronic configuration, and recurring chemical properties. It then means that the classes of elements were based on their atomic number, also electronic configuration, as well as their recurring chemical properties. The periodicity of elements refers to the trends or recurring variation in elements' properties with increasing atomic number. Periodicity of elements. Periodicity is caused by regular and predictable variation in the elements and their atomic structure. The atomic structure of elements helps us a lot to tell you the group and period an element is placed on. Now, we are going to look at the periodic laws. One will expect that we will say periodic law. Of course, before we arrive at the final periodic law, there were other periodic laws that came before them. Because of their irregularity and inconsistency, and as a result of anomalies that came by, these laws were further modified. The first law was the fact that it was on the basis of atomic mass, and it was referred to as old periodic law because it couldn't stand the test of time. The old periodic law states that the properties of elements on the periodic table are the periodic function of their atomic masses, which means that then elements were arranged in order of their increasing atomic masses. Now, there was a problem between argon and potassium. If you look at it, you find out that the atomic mass of potassium is 39.098 and that of argon is 39.948, which means that argon has a bigger atomic mass than potassium. So based on the arrangement, potassium will come before argon, and by so doing, potassium was placed in the group 8 element while argon was placed in the group 1 element. Their position could not be accounted for by their properties because the group 8 elements were inert while the group 1 elements were very reactive. Hence, argon could not withstand the reactivity of group 1, as well as potassium could not withstand the inercity of group 8 element. As a result, there was a need for a modification of the periodic law. And that brought us to the modern periodic law, which states that the properties of element on the periodic table is the periodic function of their atomic numbers. Hence, elements are arranged on the periodic table in order of their increasing atomic number. From hydrogen with atomic number 1, and maybe at SS3 you will stop at 30th element, which is zinc, with atomic number 30. There are relationships on the periodic table, and these relationships are broadly classified into 3. We have the vertical relationship, which is usually from up to down, and it is called a group or vertical column. Elements on the same group have the same number of electrons in the outermost shell. In other words, it is called valence electron. The other one is the horizontal relationship, which is from left to right. From left to right. It is called a roll. And elements on the same period have the same number of shells. The last one is diagonal relationship. Diagonal relationship has to do with diagonal neighbors, which are of comparable sizes. I will show you the periodic table and how this relationship exists. If you look at it from up to down, or from up to down, is called a group. And that is why these elements are grouped into group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Of course, I told you that from left to right is called the period. And this period is also known as a roll. Elements on the same period have the same number of shells. The last one is diagonal relationship. You appreciate this colored element in red color. It shows that they are diagonally related. And if you look at their diagonal relationship, it tells about their sizes. They are of comparable sizes. It affects some of their properties, as you can see it on the board. Now, we'll talk about also, sometimes in examination, you are asked to tell the position or the group or period an element belongs to. If you use the electronic configuration, you can tell what group and what period an element belongs to. For instance, aluminium. Aluminium have the electronic configuration of 1s2, 2s2, 2p6, 3x2, and 3p1. Now, the period is always shown by the outermost shell. The outermost shell in this context is 3s and 3p. It means that aluminium is in period 3. Let's find out whether this is true. This is period 1, period 2, and period 3. If you follow it, you find aluminium to be here on period 3. Now, how do you get to find out the group it belongs to? The group it belongs to is based on the number of electrons in the outermost shell. And the outermost shell, 3s2 and 3p1. So if you put 2 plus 1, it gives you 3. It means that aluminium is on group 3, period 3. Let's look at it from here. Period 1, period 2, period 3. Group 1, group 2, group 3. Behold, you have your aluminium. So you can use that same standard for other examples below. Let's quickly look at fluorine there. Fluorine is 1s2, 2s2, and 2p5. The outermost shell, of course, is 2, which is 2s and 2p. So it means that fluorine is in period 2. And of course, the number of electrons in the outermost shell is 2s and 2p. And 2s is 2 electrons, and 2p is 5 electrons. So 2 plus 5 gives you 7. So it means that fluorine is in group 7. Let's find it out. Period 1, period 2, group 1, group 2, group 3, group 4, group 5, group 6. And behold, fluorine in group 7. So in an examination, if you are asked to find out the group or period of an element, once you can write the electronic configuration, the rest will be as easy as ABC. My wonderful students, hoping you are enjoying the lessons already. Now, I would like to tell you the classification of the periodic table. The periodic table can be classified on several bases. But one of the bases I want to lay emphasis on is the position of the differential electron. The differential electron is usually the electron in the outermost shell. And because of that, elements are grouped into S block elements, P block elements, D block element, and F block elements. Now, the S block element have their differential electron or the outermost electron found in the S subshell. And that is why you have the group 1 and the group 2 elements are the ones that are called the S block element. Why? Because their outermost electrons are found in the S subshell. Let's look at the example. You can see hydrogen is 1s1. The outermost subshell is S, 1s. and that's why it's called s block element. Looking at lithium, the outermost subshell is 2s, and that is why the outermost electron is found in 2s. That's why it's called s block. Let's talk about magnesium. Magnesium have the outermost shell as 3s, and because s is the outermost electron, where an outermost shell, where you find the outermost electron is called an s block element. Remember, I say s block elements are elements of group 1 and group 2. Let's look at the p blocks elements. The p block elements also have their differential electron in the p subshell. So you can see in boron 2p1, in fluorine 2p5, in aluminium 2p1. It indicates that they are p block elements. The d block elements have their differential electron in the d subshell, as can be seen in scandium 3d1 and iron 3d6. Of course, the f block elements, your scope has not reached that level, but I would like you to know that they are also having their outermost electron in the f subshells. Let's see the classification of the periodic table once again. You can see that the periodic table can be further classified into s block element 1 and 2, p block elements 3 to 8, d block elements from in between the s block and the p block. These are the d block elements. And of course, the f block elements that are listed below here. So you can see S, P, D, F. Meanwhile, you know that S stands for sharp, P stands for principal, D stands for diffuse, and F stands for fundamental. We'll look at further classification of the periodic table as in the terms of main block element or representative element. These are elements of the S and P block. They are called main block elements because they show resemblance in their chemistry. And they are called representative elements because one element can be used to represent the whole group. For instance, the group 4 elements are called the carbon family. The other one is the transition elements. The transition elements are in between the S and the P blocks. Remember I said they are called the D blocks, but we don't generalize them as D blocks because there are exceptions of elements that are not in the D block, like zinc, cadmium, and mercury. So if you are asked to define transition elements, you say these are elements that have partially filled, low-lying d orbitals. These are elements that have partially filled, low-lying d orbitals. They have special characteristics like variable oxidation state. For instance, copper and iron can exist as ion 2 and ion 3. They have ability to form colored compounds. Most of the compounds of transition elements are colored. For instance, copper 2 tetrahydrosulfate 6 is blue in color. Ion 3 tetrahydrosulfate 6 is brownish in color, and so on and so forth. So we have other properties like ability to form complexes, catalytic behavior, and magnetic properties. And if you look at magnetic properties, you will see that there is diamagnetism and there is paramagnetism, as the case might be. My wonderful students, you find out that there are inner transition metals that is further divided into two. It's either lanthanide series, that is they behave like lanthanum, which is an element on the periodic table, or actinide series that behave like actinium, which is also an element on the periodic table. Now, if you look at this classification further, we will see that the group 1 elements are called the alkali metals, the group 2 elements are called the alkali earth metals, the group 3 elements are called the boron family, the group 4 elements are called the carbon family, the group 5 elements are called the nitrogen family, the group 6 elements are called the oxygen family, and the group 7 elements are called halogens. Another name for halogen is salt formers because they easily form salt. Of course, the group 8 elements are called inert gases, real gases, or noble gases because of their stability due to octet or duplet configuration. I'll quickly look at the properties of elements, periodic properties of elements, and their variation on the periodic table. One of them is the atomic size, which is also called atomic radius. And we say this is half the internuclear distance between two identical atoms that are covalently bonded together. And if you look at it, it says atomic radius increases down the group and decreases across the period. The second one is ionic radius. And I say ionic radius is the actual size of an ion in an ionic environment. It can be anions, it can be cation. The next one is electropositivity. Electropositivity, this is the ability of an element to lose electron and become positively charged. It's the same thing as metallic character. You find out that electropositivity increases down the group and decrease also across the period. The other properties are ionization energy, which is an energy. Ionization energy is the energy required to remove the most loosely held electron in the outermost shell of a gaseous atom or ion in its ground state. These definitions are very, very important because, like I said in my previous class, they are either 2 marks or 0. It's either it is correct or incorrect. Ionization energy decrease down the group and increase across the period. The next one is electron affinity. It's the energy release when a gaseous atom in its ground state is converted to a gaseous anion. And just like ionization energy, it decreases down the group and increase across the period, with the halogens having the highest electron affinity as well as electronegativity. Electronegativity is the ability of an atom to attract electron to itself in a chemical bond and become negatively charged. So it decreases down the group and increase across the period. This is periodic table and periodicity of element. My wonderful student, it has been an exciting moment with you. I would like to invite my colleague, my noble colleague, Mr. Ibrahim Umar, aka Iro, as he comes forward to give you a summary of the presentation. Have a wonderful day.
Thank you very much, Mr. Philip Maman, the energetic chemically Philip Maman. All right, my noble students, my name is Uncle Ibrahim. I'm happy to see you once again. I'm here to give you a quick recap of what Mr. Philip has discussed before I invite Mr. Williams to come and give you assignments for you to practice at home. First of all, he has said a lot of things, and he said them very well, so I don't need to say it over and over again. But first of all, we have to define periodic table. He defined it, and you have to know that it is a chart in which elements are arranged in order of their increasing atomic number. Very important. It is arranged in order of increasing atomic number. And also, he captured that chemical properties, physical properties, and some other properties reoccur after an interval. That means when you have group 1 element, they will come back to group 1 element again, and then their properties will be the same. Having said that, I'll move again to features of the periodic table, or at least classification of the periodic table, in which they were classified as vertical relationships, or the relationship generally. The vertical relationships, the horizontal relationships, and then the diagonal relationships, also known as groups and periods. Now, as you can see from the table here, we have groups. We have the main groups and then the transition group. The main group of the periodic table is talking about the number of outermost electrons in a shell. So an atom is said to be in group 1 when it has 1 valence electron in their outermost shell. It will be in group 2 when it has 2 valence electrons in their outermost shell, and so on and so forth. It is important to know that elements on the same group have similar chemical properties. They have all their reactions similar, and then they only have small variation in terms of the periodicity. That will brought us to what we mean periodicity. But before I go to periodicity, then we have the periods. The periods are the horizontal relationship, horizontal in a straight line like this. A horizontal relationship gives rise to period, which is period 1, period 2, period 3, up to period 7. It is important to note that elements are said to be in the same period when they have the same number of shells. All the elements that are having only 1 shell belongs to period 1. Those that have 2 shells belongs to period 2, and so on and so forth. Very important are the names of this period. They are called family because they resemble one another. Those in group 1 are called alkali metals because they are the most reactive metals in the periodic table. Followed by the group 2 element, which are the alkaline earth metals. Then group 3 are boron family because their father here is boron. Then we have group 4, which is the carbon family. Why? Because their father here is carbon. Then nitrogen family, oxygen family, and of course, the most reactive non-metals, which are the halogen, group 7. They can easily react using electrovalent bonding. It is also important to take note of this, that whenever there is a reaction between a metal and a non-metal, then ionic bonding is expected because the metals can easily lose their electrons. This gives rise, because they have a very high electropositivity, they can easily lose their electrons. And then the non-metals have a very high electron affinity. They love electrons, so they can easily accept it. And that is why the non-metals form electrovalent bonding or ionic bonding with the metals. It is important because you might expect a question. When you are given a question, they will tell you what is the type of bond that is expected to exist between two elements. So once one of the elements is a metal, the other one is a non-metal, then you should know that ionic bonding exists between a metal and a non-metal. And finally, which is one of the things I would like to discuss, from the table, he made mention of it. You see it clearly that the first two groups are called the S block element because they have their own electrons, the last electron filling the S orbitals. They are the first two groups. These are the S block elements. These are the P block elements. These are the D block elements. And finally, we have the F block elements because they are filling the last, they are partially filled F block elements. Having said that, my wonderful students, we have a lot of things to discuss, but at least I want to believe that we have done justice to discuss. If you have any problem, I will introduce my able colleague, Mr. Williams Ishaku, to come and give you a sample questions as well as our contact so that you ask for further explanation. Thank you very much.
Hi, my wonderful student at home. Once again, my name is Mr. Williams Ishaku. I believe you have learned a lot from this presentation, beautifully presented by my able colleague, Mr. Philip Mamam and Mr. Ibrahim Umar. I am here to read out this assignment for you so that you can try them at home and then get back to us. The first one is this. Question number 1. State the group and period the following elements belong to and the periodic table. The elements are, we have aluminium with atomic number 13, calcium with atomic number 20, phosphorus with atomic number 15, and argon with atomic number 18. Question number 2. State the properties of transition element and explain them. Question number 3. Explain the reasons for the variation of the following on the periodic table. The I1 is atomic radius. The I2 is ionization energy. The fourth question is determine the atomic volume. And question number 5, list 2 types of catalysts and 5 characteristics of catalysts. Again, question number 1, state the group and the period the following elements belong to on the periodic table. The first element there is aluminium with atomic number 13, calcium with atomic number 20, phosphorus with atomic number 15, and argon with atomic number 18. The second question, state the properties of transition element and explain them. Question number 3, explain the reasons for the variation of the following on the periodic table. The I1 for the question number 3 is atomic radius. The I2 is ionization energy. The question number 4 is define atomic volume. Question number 5, list 2 types of catalysts and 5 characteristics of catalysts. My student, in case if you have any problem or you would like us to get you to to get your work at the course of this assignment. After finishing this assignment, you can always contact us via these numbers. My WhatsApp number, we will prefer you using WhatsApp because it is easier. Mr. Williams Ishaku, 081 606 70920. Again, 081 606 70920. For Mr. Philip Mamam, we have 082 659 8861. Again, 082 659 8861. For Mr. Ibrahim Umar, 070 362 02842. 070 362 02842. My wonderful learners, remain focused and keep on learning. We hope to see you once again in our subsequent edition. Thank you, and may God bless you.